Alright.
Are
you okay?
Yeah, I was just tired.
Oh, I am too. On Monday, I only got like 3 hours of sleep.
Yeah, it's just getting harder and harder to sleep now.
Yeah. It's midterms.
Yeah, definitely.
I had like 3 tests last week. This week too.
Yeah. Last week I had 3 tests. This week, today, I have a chemistry lab midterm. And then I have a math test on Friday.
Are you worried about the chem lab midterm? Do you need help with that, or?
Yeah. Oh, I wonder if I have my study. Do I have my study guide with me?
I have just a warning. I might not know much about the lab.
Yeah, well,
I haven't done it in a while.
I thought. Well, I'm trying to figure out what did she tell us. Cause like I'm not really like sure the instructions about like the lab, like how she's gonna do it. She told us we're gonna be performing a lab, but I'm not sure like which one or what exactly.
As part of the test? Oh.
Yeah. I'm like a little confused.
Mine was a written exam, so yeah, I don't know how.
Yeah, and then she's like splitting it into 2 parts. Because we have lab partners, but our lab partners aren't allowed to be in there with us during it. So it'd be a group of like people in one for the first half, because it's a 3-hour class. So it'd be the first hour and a half, and the second hour and a half the other people come in. So I'm like really confused, like what's going down today.
I don't know if I can help you with that.
Yeah, I can figure that out later.
So we're on chapter 4. Have you moved on to chapter 5 yet in your class?
Yeah, we just started. The only thing we got through yesterday, was we started with converting.
Okay.
Yeah, that's what we started yesterday. So
let us move on to limiting reactant and theoretical yield on page 169.
Okay.
Let's just drill through these problems.
Yeah.
And if you want, we can go through a couple more of the stoichiometry and molarity problems. Just remembered I'm supposed to sit on the right side of you because we learned in tutoring training that like if you're right-handed, you have to sit on the right side of your client.
Switch?
Sure, yeah.
Let's get this video perfect.
They're going to critique me for it.
That's okay, you'll be fine. I'm fine with it. Okay, cool. You sat on the right side of me the first time.
Yeah,
So.
it's a little cramped in here today.
Yeah.
Alright, so do you want to start with theoretical yield or do a couple more of the stoichiometry or molarity problems?
I think I got those.
Okay.
Yeah, I'm good with those.
Then let's go to limiting reactant. Number 13 says, for the reaction shown, find the limiting reactant for each of the initial amounts of reactants. So I'm just going to write that down.
Okay, so part A is 2 moles. A and 2 moles.
So what do you think is the first step?
Limiting reactant is the reactant that we like don't need, or is the one that limits us from creating like the full
product.
Yeah.
Okay. So how do you think you figure that out? You know, in stoichiometry we start with what's given. So in part A, what's given is 2 moles of Na and 2 moles of Br2. And it's a lot like stoichiometry in that you start with a fraction. So 2 moles of Na over 1.
probably my hard part. And then we do that times the moles of Na we have here.
Mm-hmm.
Do we use it in the first side or the second side though? Would it be before the product side?
Yeah.
Okay.
So, because this is NABR, which is a different kind of compound. And do you put it in the numerator or denominator?
The denominator.
Mm-hmm.
Yeah. Because it has to cancel out. So it'd be 2 Na then?
2 moles of Na. And then in the numerator, what would you put on?
1 mole. No. Oh, do you put the...
This is a hard one.
Yeah. Do you put the 2 moles of Br2 there? No.
What you do is you put the product there, because that gives you the amount of product that will be produced from 2 moles of Na.
Okay, so what would be one huge equation then? I mean, one huge...
No, it's actually, just do this part and then I'll show you what to do next.
So 2 NABRs on top?
And on the denominator is 2 Na. And notice that this all comes from here. And then you do equals, and you calculate that.
My calculator, I'm not with that.
Oh.
It's in the front.
Here, I'll just give you. I don't want to invade your privacy.
Oh, well, this is easy now.
Yeah.
4 over 2, that's equals 2.
I went for my calculator too. Yeah, that equals 2. So 2 what?
NABR.
And then you look at the other given part, which is 2 moles of Br2, and you do the same exact thing.
Also, they're separate.
Yeah.
Oh, okay.
But because they're separate, it helps you figure out what the limiting reactant is. So I want you to do the next part of the problem.
Okay, so 2 moles of Br2 over 1 times the numerator would still be 2 NABR.
Yes.
And then the denominator is Br2. 1 mole of Br2. And that will equal 2 moles of NABR. Also.
Will it?
No. Oh, 1 mole. Wait, 2 times 2 is 4.
Yeah.
Yeah.
It's okay.
Okay. So the limiting reactant would be the... What?
It would be whichever one creates the least amount of product.
So it'd be the NA.
Yeah,
So
so that one's Na. And let's try B now. And you try B.
okay. 1.8.
I actually did these problems last night, so I know what the answers are. Just for funsies.
Yeah, tonight, after I finish my lab tonight and I have a presentation tomorrow, I'll be clear to actually start studying in chemistry again.
Yeah. I know how it feels to be after that.
I wouldn't do it. Okay. Okay, so this one, the NA is also the limiting reactor. Yep.
All right, so I think you got that down.
Yeah.
Let's move on to. I don't know about 15.
Yeah.
Doesn't look like.
Yeah, we've never done pictures before.
Yeah, I don't think they would ask something like that on the test. So let's do 17. So what do you think is the first step?
So do we start off with the same thing as 4 moles TI over 1?
Mm-hmm.
And then, because the theoretical yield is the product, right?
Yep.
Okay.
Mm-hmm. Because it says the theoretical yield of the product.
Mm-hmm.
So you're basically doing what I showed you in
The
the
same
last
thing.
thing.
Yeah.
Really, the last one you could have used just common sense
Yeah,
to figure out,
Mm-hmm.
but that's how you find the theoretical
Because
yield
the
too.
numbers. Yeah.
Mm-hmm.
Mm-hmm. Okay, cool.
So we could skip to 19. Is that
Yeah, that's the same
involves-
thing. I'll say the initial amounts of reactants. So do we have to use conversions since it's in grams?
Mm-hmm. But it's basically the same as the last two, except you just convert moles to grams at the end.
Okay. So, okay. So we have 2.0 grams of milk. Of 1 times the initial amounts of it would be the denominator is still 1. Wait, what's the denominator? Of 2. Wait.
No, it has to be grams in
Mhm.
the denominator. So where can you find grams of aluminum?
The table.
Mm-hmm.
You have to use that thing.
Yep. The hands are always clammy.
Okay. 26.98. would be over 1. No, it's over the initial.
Oh, you mean in the numerator?
Yeah.
Yeah, that'd be over 1.
Okay.
Because that's 1 mole of aluminum that you're describing with the grams. And then what do you think you'd do? 26.9.
Would that be all for this one? Just calculate it?
No. Because if you stopped right there, you'd only get you'd get moles of aluminum.
Mm-hmm.
What you need is moles of AlC3.
Oh, okay.
Yeah, because that's the product.
Mm-hmm. So we'd put 1. Hold on, not 1. Okay, so 2 moles of. No. How many moles? Okay, 2 moles of AlCl3 at the denominator. No, numerator?
Mm-hmm.
Why is it at the numerator?
The numerator is because you have to make the moles of aluminum diagonal.
Oh, okay.
So you put the 2 moles of
We have to
aluminum.
cancel out that
Yeah.
one first.
Yeah.
Yeah. Duh.
AlC3. And then, do you think there are any more steps?
That's canceled. No, that's it.
Mm-hmm.
Okay.
So that will give you the theoretical yield of AlCl3. Yeah, 0.074.
0.74.
Maybe I did it wrong. 2 times 2, 4 divided by 26.98 times 2.
Times 2? Why did I do that? Oh. I did something.
Did you put it over 1 mole of Al?
Mm-hmm.
Yeah. This one comes from the reaction, so you have to pull it from there.
That's good to know. I remember like struggling with this in last week's test.
Let's see. Alright, so now that we have this, oh, actually, it said to find it in grams.
So we have to now switch it to
Yeah, so we have to still, yeah, okay. So take 0.074 moles. Here for 1.
And we have to cancel out the moles. To be on the denominator to be 2 moles of AlCl3.
Not in this case, because when you find them, when you're doing a fraction or whatever you want to call it of molar mass, because we have to find the molar mass of that, you're describing the mass of 1 mole of that compound, not 2.
Okay.
So if you wanted, you could do like 2 moles of AlC3 and then find the mass of 1 mole and multiply it by 2, but that would just be really complicated and you don't want to do that. So how do you think you find the molar mass of that?
Do we add both of the, what's it called, both of the elements together? Okay.
And you'd have to multiply Cl
by 3.
by 3.
35.45 times 3. And 26. So 133.33.
Yeah. I got something different because I used the wrong element. So, let's see. Cl 35.45 times 3. 133.33? Yep.
And that'll be grams per mole? Or just grams?
Just grams.
Okay.
Because the per is right here.
Oh, duh.
Per 1 mole.
Yeah.
See how that works?
Yeah.
Okay. So now you just multiply that across. But that actually wouldn't give you the answer yet because you don't know which one of these is the limiting reactant. You could just, with common sense, actually, yeah, with common sense you could just say like, since, oh never mind, forget everything I just said. Okay. So this is 9.866 grams of AlC3. So yeah, the problem isn't finished yet. You still have to convert this to the amount of grams of product will come from it. So 2.0 grams of Cl3. Because we just did 2.0 grams of Al.
Also, we can do both sides too. Okay.
Careful.
What am I doing wrong?
You're looking at the right thing.
Yeah.
But notice that this is Cl2. So 1 mole of Cl2.
So you do twice.
Yeah. So you have to multiply Cl by 2. I got stuck on a problem like that when I was in Principles of Chem 1 for like 30 minutes. And I just did not know what I was doing wrong. It was bad.
Oh, because it's like the multiple choice answers? And you're like...
No, like I was looking at the answer in the back of the book.
Oh.
And it was wrong. And I kept getting it wrong. And then I finally realized, oh,
this is why.
Just multiply it by 2.
Okay. Okay, so it will be multiplied by 2 moles of AlCl3 over oh, the problem.
Yeah.
Stephanie, your 2:30's here.
Oh man,
Why did you?
okay.
Okay. Well, I can finish this up and
You want to send me the answer and I'll check it?
Okay.
That sounds good. Thanks for letting me record.
Thank you for your time today.
You're welcome. I hope you have a great rest of the day.
You too.